household electricity. We're all so used to going into the house, flipping on the light, and the lights come on. Or plug something up and get the electricity that goes with it. But there are so many lessons that you can do with electricity. There's all kinds of terminology that you can use, and actually if you can find somebody, maybe a retired electrician or somebody that's a good handyman that can explain this better than you can, it might even be a good idea to bring somebody in. I'm not really very good with electricity, but it is something that can seriously hurt you, so if you don't know what you're doing, then don't do things that you don't feel comfortable doing. And certainly don't ask your kids to do things that you don't feel comfortable doing. But electricity, there's all kinds of lessons you could talk about where electricity came from. Comes from coal, comes from oil, comes from water, comes from nuclear, gas, even wind. All of those things produce electricity, so it would be an easy lesson to talk about those things. Motors have copper wires and batteries that we use. Those kinds of things are electrical in some form, not the same way that we think about house electricity, but those motors like in our car or our battery, those kinds of things do the same type of electrical process. Different things pull different amount of voltage. Obviously voltages are a conversation that you could have, a vocabulary word that you could use. Motors, hair dryers, microwaves, all of them have different voltage that they pull. That's one reason why we can talk about 120 voltage and 240 voltage. Your dryer at home has a special plug-in, and your stove at home, if you have an electrical stove, has a different plug-in because it pulls different wattage. Electricity is obviously transported by wires, and it works just like water flowing. You've got to have a wire to get from from point A to point B. Water runs in pipes. Obviously electricity runs through wires. The size of the water pipe determines how much water comes out. The size of the wire determines how much electricity comes out. That's why when you see big towers that are holding up electrical lines, some of those lines are actually very huge. There's potential energy involved. There's lessons that could go with that. There are conductors like copper and steel and aluminum that transport electricity. They have to have an odd number of electrons. Obviously, there's things that have to do with the periodic table, the electricity, or the electrons that bump from one element to the other, and how they bump into each other, those kinds of things. Currents have to run in a pattern, and that's why they're called electrical currents, is because there has to be a circuit that's involved. If any of you are good old country people that have been around an electric fence, if you've ever stood by the electric fence and someone was standing beside you, if you hold that other person's hand and then touch the electrical fence, you don't get shocked. You're in the middle of that circuit, and so the electricity just flows through you, but it flows into the person on the other side. Now, if they jerk loose and leave you holding the fence, then you're going to get shocked. But all of that has to do with a current and has to do with how electricity flows. Years ago, people used to have fuse boxes. Now they have breaker boxes, so that's a conversation that you could have. Insulators, things like rubber and plastic and paper and wood and glass, have almost no electrons, and so they don't conduct electricity. That's why they are considered to be insulators that keep electricity from shocking you. Of course, there's AC electricity, which is alternating current, like in your house. There's DC current, which has to do with like the battery in your car. There's amperage and amps, which has to do with the number of electrons flowing past one point in 1 second. That's what the word amperage means. There's voltage that you could talk about, which is the pressure that exists to restore electrical balance. There's voltage meters that you could talk about. Extension cords even have a lesson in them about electricity. Wattage in your light bulb, what kind of wattage you have, if you've got a 25 watt light bulb in your appliance, or if you've got a 100 watt light bulb on your outside security light. But there's hundreds of different lessons that you could do. I brought an example for you today. If you know someone that can hook you up a little setup where you can show a little bit of this, then that's a good thing as well. I never did know until I started doing this. The little hole right here is a safety feature. That's why some 3-prong plugs, you have the little prong that goes in there besides the 2 main plugs. That is for safety purposes. It's a mechanical ground. That mechanical ground is normally a copper wire, and I don't know whether you can see the colors or not, but there is a copper wire attached to this plug because this plug is grounded. Okay, that means that the electricity will run from this plug through the wires in your house to the outside and into the ground where it is attached to a ground. And that's why that's called a ground wire. All of those are safety mechanisms because you can certainly get hurt, killed, hurt very badly with electricity if you don't know what you're doing. Normally in an electrical setup, the white wire, I'm going to unplug this while I'm talking. The white wire is normally the neutral. The ground is either a bare wire, which is the copper wire I talked about, or sometimes it will be green, depending on what that person is using. But if you hear a pop or if you see sparks, obviously you need to get away from whatever electrical appliance or setup you're dealing with. Don't try to work on electrical things unless you know what you're doing. They can be very dangerous. And obviously don't work on things while they're plugged up. That's why I just unplugged that little fellow. Water and electricity do not mix, so make sure that you think about the safety element that's involved that. Downed wires, like if you're driving your car and you come upon wires that are down across the road, be very careful about those. With accidents and with weather, don't touch those. You don't know whether those are live wires or not. When you think about how something is wired, it has to do with those terms that we just talked about. So let's look at some of those. Okay, so in your house, you come into the house and you have an electrical switch and you've got a light bulb. Now at this point I'm going to talk about how things work. So I'm going to plug my setup into the wall here. So I've got electricity. Now when you come in to the house and you turn your light switch on, okay, what's happening? The wire is going down the hot side. There's a hot side and a neutral side, and that's going to go down into, that's why the white wire and the black wire. It's going to go down into the wiring that is behind the wall and run to the light socket. The light socket is wired basically the same way. It has to have a circuit. So you can probably see here that the 2 black wires are tied together because a circuit means it makes a circle. So this has to have a wire here that's attached with a little wire nut, and the 2 hot sides are attached to the 2 tabs there, and which is going to make my light bulb work. So if I have my circuit correct, then when I turn on the light, then my light works. Now, if some of this is not wired correctly, my light bulb's not going to come on. So that's why you need somebody that knows what they're doing to be able to do that. Same principle with what happens if you have a plug-in. If I'm going to plug something into the wall, then I can put my electrical plug in here. I'll take this one out over here and show you. I'll put that in there. There's a large size and a small side on your plug, and that's the same thing that is attached. It shows here. You've got a big thick sider and a small side. They only go that way, and obviously we talked about the 3-prong plug with the safety feature. So when you plug those on, then whatever is attached to that should come on. That's how electricity works. It makes a circuit. Now, they also make switched plugs. That's what we have at my house. So you can have one switch that's hot, one switch that's neutral, and until you turn the light switch on, the light switch in my house controls the one end of this, and so you can have a switched plug where they don't work all the time, and one end does and one does not. Depends on how they are wired. But electricity is an amazing phenomenon. Lots of vocabulary, lots of scientific principles involved, but always be very careful with electricity.